Good day once again. In this video, you will be learning hypothesis testing. This is part of the quantitative methods lessons. Let us start this lesson by identifying some important terminologies in hypothesis testing. One of the most important parts in a research is the null hypothesis, and I know you're very much familiar of this already. You might have encountered yourselves with this null hypothesis term. So what is really or exactly this null hypothesis? So null is defined as having no value or amounting to nothing. Now, from the name itself, null, nothing, no value. In statistics, a hypothesis is an assumption or conjecture about a population parameter which may or may not be true. In the scientific method, the hypothesis is constructed before any applicable research has been done. So null hypothesis is the hypothesis before a research came. For example, you have a manufacturing industry. You are in a manufacturing industry of a noodles. And then your null hypothesis is there is no amount of expenses made due to a new packaging style in your product, noodles for example. That is null hypothesis. It always has the term no or no or nothing, something like that, null hypothesis. There is no amount of, there is no amount of progress that you can see in a group. And then there came alternative hypothesis. Okay, what is this alternative hypothesis? This is directly contradicting a null hypothesis. Null hypothesis says there is no improvement, there is no effect, while alternative hypothesis tries to predict, tries to prove that null hypothesis is not correct. There is an improvement, there is an effect. That is alternative hypothesis, denoted by the symbol H1. While this is the null hypothesis is denoted by the symbol H0. H0. And again, null hypothesis sometimes cannot have that, that word no. Because again, null hypothesis is the fact, the existing fact or idea na wala paghilabtan before a research. Nothing happens. And then there came a research no hilabot sa kana nga idea nga butang, then that is what we call alternative hypothesis. Okay, so that's it. An alternative hypothesis again is a statement that directly contradicts a null hypothesis by stating that the actual value of a population parameter is less than, greater than, or not equal to the value stated in the null hypothesis. It is written in the symbol H1. Okay, H1 is for alternative hypothesis. Sometimes the mean can be not equal to 100. The alternative hypothesis is less than 100 or greater than 100. These are the important things that you need to understand first before we proceed to more computations in alternative hypothesis. So if in the statements you encounter like the amount of savings that we can get if we simplify our packaging style is less than the cost before. So you choose one-tailed test. If you can see these symbols, greater than or less than. Or you can see these statements, Okay, higher than, longer than, bigger than, increase, greater than, above, and so on. As well as also here in less than, not equal, or equal to. If it is not equal, we do not know if it is less than, greater than, but it is not equal. So we use two-tailed test. So what are these one-tailed, two-tailed test? Again, to draw it, we have, for example, you are using Z distribution. So this is two-tailed test. Okay, two-tailed test. We're going to know the region. Okay, know the region. And the one-tailed test is when you only have one tail without this tail. Okay. Okay. Let us have an example. In 2015, it was recorded that around 34% of the population in 2015 were not married. Okay, 34% of the population. And then a researcher surveyed a random sample of 500 couples. He found that 18% of them were living together but unmarried. Test at 5% significance level if the current percentage of unmarried couples is different from 34%. So we can identify here that number one statement, which is the current percentage of unmarried people is different from 34%, is our alternative hypothesis. Okay, that is alternative hypothesis. While the second statement, which is the current percentage of unmarried couples is 34%, is the null hypothesis. Because again, null hypothesis is the existing fact without the research or before the research came. Okay? Another example. An average construction worker hourly rate pay in the Philippines is 62.50 pesos with a standard deviation of 6 pesos. A random sample of 20 manufacturing workers were asked on their hourly rate and found that they had an average of 50 pesos hourly rate pay with a standard deviation of 5 pesos. Construct a 90% confidence interval for the difference between the average hourly rate for construction workers and the average hourly rate for manufacturing workers. So before the survey, the known fact is that 62.50 centavos, 62 pesos and 50 centavos is the average hourly rate pay of the construction workers, taga-oras ilahang sweldo. Then there came a research, which tries to prove that 50 pesos instead of 62 pesos and 50 centavos is the average worker hourly rate pay of the construction workers in the entire Philippines. And then using the confidence level of 90%, therefore we are going to have the significance level of 10% or 0.10%. Then that's it. That is his or her alternative hypothesis. So statement number one, let us know if it is null hypothesis or alternative hypothesis. There is a significant difference between the average hourly rate for construction workers and the average hourly rate for manufacturing workers. Okay, manufacturing workers. And the other one is there is no significant difference between the average hourly rate for construction workers and the average hourly rate for manufacturing workers. So we have two variables here, the manufacturing workers and then the construction workers. And they tend to know the significant difference. If there is really a difference, let's say in the level of payment or their salaries. So obviously, statement number two is the null hypothesis and the statement number one is the alternative hypothesis. Okay, another example, one more example. A chemist invented an additive to increase the lifespan of rechargeable battery, but the said additive will extend on average the battery's lifespan to 48 months. So statement number one, the average lifespan extension of the rechargeable battery is not 48 months. Therefore, that is the null hypothesis. And then the second one, obviously, is the alternative hypothesis. Okay? Let us know what is this level of significance. We already know this already. Let us just have a review. So level of significance, for example, you have the confidence level, which is 95%. Then your level of significance is 0.05. If you have confidence level of 90%, then your level of significance is 0.10% or 0.1. So we have suggested level of significance when you are studying in public health. Public health research, you must have almost accurate or 100% accuracy. So you must have level of significance of 1% only. So that space for 1% is for the margin of error. Very little that you can commit a mistake because it is public health. While in social sciences, like in teaching and surveying about psychology, in any social sciences studies, you can have 5% or 10%. That's enough. That's okay. This implies that there is 1%, 5%, 10% probability of rejecting a true null hypothesis. Further, it implies that the result has 99%, 95%, or 90% of accepting the null hypothesis, or this is the confidence level. Okay. In symbol, it is written as, this is level of significance denoted by A, 0.01, 0.05, 0.10, and if you have, here, this one, less than or, not equal, you will have two-tailed test. Therefore, you're going to divide it by 2. Okay, two-tailed, okay, that is two-tailed. This example that I gave you here, if it is not equal here, therefore it is, two-tailed test, just like this, two-tailed test. The other half is here, the other half is here. For example, you have A over 2 is equal to 0.005. Therefore, you have 0.05 in this part here, 0.05, 0.005 also in this part, summing up to maybe 0.10 or 0.1, 0.01, okay, and so on. Okay. Let us have example. The average number of years to finish basic education is 14. A sample of 30 senior high school students were asked and found out that the mean number of years to finish the basic education is 12 with a standard deviation of 2 years. Test the hypothesis at 93% confidence interval that the average number of years to finish basic education is less than 14 years. Okay, since it is mentioned here less than 14 years, this is only a one-tailed test. Less than. Try to remember this again. If it is less than, then it is one-tailed test. Therefore, you can draw like just like this here. We go back. Here's an example. This one, example. Example you have here, make this big. You have here, for example, let me go back to my slide. So this is 93% confidence level, 93%. So you have a positive, here, for example. So since this is one-tailed test and this is positive, then you can write that or you can draw it like this. So this entire thing here is, did I hear it? Did I see it right? This is 93%. 93%. Well, this one is the rejection level or region. This is equal to 7%. Or you can write it as 0.93, and this one is 0.07. That is how you do the confidence level and level of significance, since it's less than. How about this? Okay. A sample of 100 private school students were surveyed with whether they plan to transfer to public school in the incoming school year. Results show that 40% of these students will transfer to public school. Okay, that's the average number of private school students that will transfer to public school is not 40% at 5% level of significance. So this is something to do with 5% level of significance. Okay, so again, we have the key word here, not, no, not, or not equal. Therefore, this is a two-tailed test. Okay, two-tailed test. Because again, let me go back here so that you will really be guided. Not equal, that is two-tailed test. Okay, two-tailed test. Let me draw it again. Two-tailed test looks like this. Two-tailed test, two-tailed test. Shaded region here, shaded region here. Since we have 5% level of significance, then you are going to divide it. You know the symbol already. A over 2. You know that the level of significance is 5%, so we have 0.05 divided by 2, which is 0.025. Okay, so you write it here. This is alpha is equal to, this is the rejection area. Okay, alpha means the rejection area. Okay, that is the rejection area. So 0.025. And the other side is also 0.025, summing up to 0.05, which is a 5%. Okay, I hope you get the idea, because we are going to have the problem now. Okay. So again, I have here the guidelines. Okay. Okay, this is the illustration, the one that I am drawing now. Okay, if it is less than, then you will have the left one-tailed test. If it's greater than, it is one-tailed right, yung critical region. And then two-tailed, tungaon nimo. Okay, that's it. Okay. So before we have the problem, let us have this example on how we are going to find the critical region. So for example, suppose that a normally distributed population has a standard deviation of 0.12 given a sample size 10, and then the null hypothesis is 10. The mean of the null hypothesis is 10, and then the mean of let's say the alternative hypothesis says that it is greater than 10, greater than the null hypothesis. Construct the rejection region if A is 0.05. So how to do it? We're going to find first the critical value, okay? Critical value. So I use this formula. Theta, and then the sample size, or let's say the critical region, this one here, okay, is equal to standard deviation over the square root of the sample size is equal to 0.12 over square root of 10 is equal to, use calculator, and then you will have 0.03793 or 0.038. Okay. And the next is, notice that the alternative hypothesis suggests that the mean of the null hypothesis is greater than 10. No, this is one directional test, greater than, therefore dito sa right side, less than sa left side. Using the standard normal table, okay, we are using the standard normal table this time. Okay, so we use the standard table. Okay, you have your standard table or Z table, right? The one that I presented to you earlier. Okay, I don't know if I have it here, but again, you know how to use it naman, the Z table. Like, we're going to find first the 0.05. Where does it belong? Okay, where can you find 0.05? Okay, hold on, let me pause the video and then let me show to you. Okay, so here. So you have 0.05 in the Z table. So you use the standard cumulative standard normal distribution. Okay, here 0. Diba, we already solved it in the second video. This is at the center, so that means 0.05 is somewhere here, center. So 1.645 center here. Okay, that is how we get it. Okay, so you have Z of A. And then critical value, you have to find it, use the formula now since you already solved the Z of A. And then you also solve the theta population mean. Okay, so you will have the mean plus the product of Z of A times theta population mean. So that's it. And then you will have 10.0624. That is now the critical region or the rejection area. Okay, 10.0624. And then our alternative hypothesis said that the correct let's say the correct number, for example, in this example, is greater than 10. Therefore, we reject the null hypothesis. Therefore, alternative hypothesis is correct. That in this example, for example, there are 10 students who are not failing. Okay, not failing. So alternative hypothesis is correct. If it happens that the critical value is the suggested here in the alternative hypothesis is equal to 10, then it is not correct. Okay, since the said here is 10.0624. That's it. And okay, before we have the computations, let us know first the types of errors in hypothesis testing. Type 1 error is committed when rejecting a true null hypothesis. No? We rejected the true null hypothesis because of the wrong computation. Type 2 error is committed when accepting a false null hypothesis. We accepted the false null hypothesis. That is type 2 error. Just to give you a tip or a clue, this is the most commonly used level of significance. You can see this 0.05, 0.01, 0.001. So if you're going to conduct a one-tailed test, you have these value, the critical value. And then the two-tailed, you have these. Okay, take a picture so that you can know this and this. Okay, try to know this. It is very easy to know how to use it because we have this and this. Okay, let us check if it is correct. 0.05, 0.05 somewhere here. Diba? We know it already that 1.645. Here, 1.645. How about two-tailed? This one is for one-tailed, and then two-tailed we can use, since this is 0.05, we can use this. Now this type of normal Z table, 1.9, answer here, 1.96, let us see if it is correct. 1.96, yes. So 0.05 is located somewhere here, 1.96. It is, if it is in two-tailed, okay, two-tailed, and then you are going to divide it by 2 pag yun, okay, that is 0.025. Okay, we're almost done, but still we are going to know how to solve it in real life examples, so that you will know why are we learning this, okay? And then how can you and then you can apply it in your real life experiences or in your future jobs. Okay, so let us read first the problem. A factory has a machine. Let me just make my screen a little bit bigger so that you can see. Okay, so a factory has a machine that dispenses 80 ml of fluid in a bottle. Okay, try to remember this one. This could be the null hypothesis. 80 ml of fluid in a bottle. An employee believes the average amount of fluid is not 80 ml. Using 40 samples, he measures the average amount dispensed by the machine to be 78 ml with a standard deviation of 2.5. Okay, so state the null and alternative hypothesis. Okay, based on this problem, let me make this bigger so that you can see my screen. Okay. Null hypothesis says that the mean, I hope you can see this clearly, is equal to 80 ml. Okay, 80 ml. While there came an employee, tries to prove that the null hypothesis is not correct. So he said that the alternative hypothesis, that the mean is not equal to 80. Okay, not equal to 80. And we have our sample size, which is 40 based on the problem. Sample size which is 40, and then the dispensed by the machine to be 78 ml. Okay, 78 ml. Okay, that is with a standard deviation of 2.5. Okay, standard deviation of 2.5. Standard deviation, let me write it here. Standard deviation is 2.5. This is 2.5, and the next is, okay, the question, at a 95% confidence level, is there enough evidence to support the idea that the machine is not working properly? Okay, is not working properly. Okay, not working properly. So 95% is our confidence level, but we need to only use the level of significance. So the level of significance, or we call it as A, is equal to 0.05. And then since here, okay, since it is mentioned here that employee believes that the average amount of fluid is not 80 ml, diba? Not 80 ml, not equal. not equal is equivalent to two-tailed test. Two-tailed test. So let us see if we have this answer, two-tailed test. Let us now proceed to the two-tailed test. Let us draw it using the given values. Let me make this bigger because you already have seen the given. Let me try to make this a little bit perfect. Okay, so this is, for example, your Z table, because based on the problem you have 40, diba? Greater than 30. Therefore, we're going to use the Z distribution. Okay, Z distribution. Again, if it is less than 30 or equal to 30 and less than 30, then we're going to use the T distribution. So here we have this alpha value 0.05. Since we have two tails, no, we're going to divide it by 2. So 0.05 divided by 2, that is 0.025. This is now the rejection area. The other one as well, 0.025. We call it as the alpha. Okay, that's it. And here, this is now what we call the confidence level, 0.95, summing up to 100. Next step is we are going to use the formula, this formula here. Excuse me. We have 7 is equal to x minus, no, this is the average, okay, minus, okay, over standard deviation over square root of n. So the population mean minus the suggestion of the hypothesis, okay, the null hypothesis, which is 80. So again, this is the population mean. Our population mean here is 78. So here, let me go back to the slide. Here. It is mentioned here in the alternative hypothesis, this is the expected 78. While the MO, sub O or 0 for the null hypothesis is the existing fact, and this is for the alternative hypothesis. So you have 78 here minus MO or M sub 0, which is our null hypothesis suggesting. Okay, I hope you get the idea. So let us substitute now. Okay, this is 78 ml. 78 ml minus 80 divided by standard deviation is 2.5 divided by square root of 40, which is the sample size, and let us use the calculator in solving it, and then 78 minus 80, that is negative 2 over 2.5 divided by square root of 40, that is, let us solve this in calculator. So 2.5, hold on, can do it. 2.5 divided by square root of 40, that is 0.3, I don't know if I got it right, square root of 40, 6.328, and then 2.5 divided by, so the answer is 0.395, 0.395, so subtract it, negative 2 divided by 0.395, that is equal to 5.0635. So 5. this is negative. Negative 5.06. Let's have it shortened. 5.06. Okay, so where can we look at this 5.06? So this is now the value of z here. So by the way, so we need to locate first the rejection area. Okay, so rejection area here is 1.96. 1.96. How did we get this 1.96 here? Okay, 1.96 and 1.96 also here. Using this say, hold on. Let me go back to the suggested one. Okay, here. Okay, 1.96. Since we have 0.05. Now, since this is two-tailed, then we have 1.96 here, okay? I hope you get the idea. And you can use the normal distribution table like this or this to find the answer. Okay. Okay, let's go back to the problem. Again, that is 1.96. This is the rejection area. Try to remember. This is the rejection area or region. The same also here. This is the rejection area region. Then, since our critical value is negative 5.06, that is somewhere here. Negative 5.06 included in the rejection area. Therefore, we are going to reject the null hypothesis. Reject the null hypothesis. That means the alternative hypothesis is correct. It is correct. That the average amount of fluid is not equal to 80 ml. It proves here that 78 ml is correct. Okay. This is how you do the hypothesis testing. You are trying to reject or accept the null hypothesis. But if the answer is, for example, the answer here, we have came up with the answer of 1.7. So 1.7 is here. So it is part of the no confidence level. Therefore, we are going to accept the null hypothesis na pod. Because, we believe that null hypothesis is correct. Nga 80 ml yun. That's how you do the hypothesis test. How about example number 2? Okay. Example number 2. Let me erase my writings while I am reading. Sige. A company manufactures car batteries with an average life span of 2 or more years. An engineer believes this value to be less using 10 samples. He measures the average lifespan to be 1.8 years with a standard deviation of 0.15. Let us list first the given. So what do you think is the null hypothesis? Hold on. Let me make this okay. Null hypothesis here, H sub 0 is equal to M is less than or equal to 2. Since it is mentioned here, a company manufactures car batteries with an average lifespan of 2 or more. So equal to 2 or more, greater than 2. And then the alternative hypothesis, H1, is it suggests that the mean is is less than 2. Okay, less than 2, no? Kanisha. An engineer believes this value to be less. Okay, less. Using 10 samples. Okay, let us list na lang the given values, 10 ang atong sample size. And then he measures the average lifespan to be 1.8 years. So nanatay this average of the alternative hypothesis, which is 1.8. Next is the standard deviation, which is equal to 0.50. And then, okay, let us analyze. It mentions here that it is less than 2. And let us try to go back to our slides. Okay, this is less than 2. Here. Since it is less than 2 here, we're going to have a left side one-tailed test, this one. Okay, so hold on. Okay, so let us draw this thing here and here. This is a one-tailed test. So one-tailed test, since this is less than, it should be somewhere here. Okay, and try to remember, okay, the sample size is only 10. This is less than 30. We're going to use t distribution this time. So the formula for finding the t distribution is t is equal to the suggested average for the alternative hypothesis minus the suggested average for the null hypothesis, which is 2. Okay, let me write it first, the formula first, divided by, okay, that is divided by the same, s over square root of n, and this one is 2 minus, okay, hold on, this is 1.8 minus 2 over standard deviation 0.15 divided by square root of 10. To make it short, the correct answer is negative 0.2 divided by 0.04 blah blah blah, and then you will have the t value, critical value of negative 4.22. Okay, and here again we have here, okay, 99% confidence level. So confidence level is 99%. This is 0.99. So gamay ra ka na diri. 0.99, and this one here is 0.01. This is the alpha. Okay, 0.01. And let me make it bigger, 0.01. And what is the critical value here? We are going to find. So critical value is using this table that we have, the suggested and more used one-tailed test. This is positive, this is negative, so negative 3.09, negative 3.09, negative 3.09. This is 0. Negative 0.1. Okay. Therefore, let me make it bigger. Therefore, negative 4.22 is somewhere again inside the rejection region. Therefore, again, we are going to reject the null hypothesis. That means that now the statement, which is 1.8, okay, 1.8 years is the average lifespan of the batteries, of a car batteries. That's it for this video about hypothesis testing. I hope you learned a lot for this video, and thank you so much for watching. Kindly answer the activities. Thank you and good day.